Okay, we want to prove or is not countable. So the real set is not countable. So we're required to prove, or this can be done if we can just show that there exists a subset A of the real set that is not countable. Um, so as long as I can find a subset of A of or that's not countable, then the whole thing isn't countable because some part of it is not. So let's say let A equal the set um, X where X is between 0 and 1. Well, actually, okay. X is real. It's between 0 and 1. And it's formed using digits 0 or 1, e.g. 0.111011, whatever, in base 10. I'm saying in base 10 because I don't want you to think I'm using binary. I'm only looking at the numbers between 0 and 1 where you use the digits 0 or 1 to form the number. The reason for this is because some weird stuff can happen if you're using the digit 9. A recurring 9 is the same as 1, and 0.9 recurring is the same as 1, and so on. So just to prevent any confusion or messing about, we'll just have only the numbers 0 and 1. Now, I'll claim A is countable. So that means we can write A um, as some sequence of numbers, A1, A2, etc., etc. Like I can list them all basically. If it's countable, I can list every element in it. So let's just say A1 is equal to 0 point B1, B2, B3, etc., etc., where BI is 0 or 1. So remember, we said that the elements in A are 0 point ones and zeros only. A2, oh, I better use a superscript 1, 1, 1. A2 is 0 point B1, B2, B3, 2, 2, 2, 0, or 1, etc. Now, let C1 equal 0 point, and I'll say that's D1, D2, D3, and D where digit I will equal. Okay, so this is what we do. If this digit here is a 1, then we'll use a 0 here. Then we go on to the second one. If the second guy is a 1, then we use a 0, and if it's 0, we use a 1. So we use 1 if BII is 0, and we use 0 if BII is 1. So for example, I'll just write an example here. Let's say A1 is 0.1101100001 and A2 is 0.000100111, etc. List them all out. Then D, oh, I don't need to call it C1 because I'm only looking at one number. So C would be 0. So since the first one here is a 1, I'd use a 0. And since the second one here is a 0, I'd use a 1. And so on. I just look at the first digit here and flip it, look at the second digit here and flip it, look at the third digit here and flip it. Now, because of such a definition, this would mean there does not exist an AK such that I can say that C is equal to AK. In other words, I can never find something in my list here that will match C because always one digit will be different. So we can't match C to anything in a 1 to infinity. So that would mean that C does not belong in A. But of course it should, because it's just an alternation of zeros and ones. So that means a contradiction. Which means that A is not countable. And of course, if A is not countable and it's a subset of R, then that means R is not countable as well.